In this video, we will discuss how uniform swelling of viscose filament yarn directly influences dye absorption and final yarn quality. Although dyeing is carried out later in the textile process, its success is largely determined during yarn production itself. Small variations in swelling behavior can create significant shade differences, streaks, and uneven dyeing defects. We will review the critical process parameters that affect swelling, understand their impact on dye uptake, and discuss the controls required to produce high-quality viscose yarn with uniform swelling. Before discussing individual process parameters, it is important to understand the fundamental principle. Uniform swelling is the single most important requirement for achieving consistent dye absorption in viscose yarn. When all filaments swell uniformly, dye molecules penetrate evenly throughout the yarn structure, producing a uniform shade. If swelling varies from filament to filament, dye uptake also becomes uneven, resulting in visible shade variation. Swelling behavior is influenced by yarn structure, viscose properties, and spin bath conditions. Therefore, maintaining only one parameter is not sufficient. Multiple variables must be controlled simultaneously. Uniform swelling serves as the foundation for consistent dye absorption, good appearance, and superior textile quality. Here it is summarized the 7 critical process parameters that control swelling behavior and dye uptake uniformity. Ripeness and viscosity determine the condition of viscose before spinning. Even small deviations can alter swelling characteristics. Sulfuric acid, zinc sulfate, and sodium sulfate concentrations control coagulation rate, fiber formation, and swelling behavior inside the spin bath. Temperature has a dual effect. Excessively high temperature reduces swelling, while very low temperature can adversely affect yarn whiteness. Tension variation influences filament structure and uniformity. The key message is that these parameters are interrelated. Keeping all of them within their specified tolerance limits is essential for achieving uniform swelling and consistent dye performance. Among all operating variables, spin bath temperature and chemical composition are the most powerful factors affecting swelling. When bath temperature increases, swelling decreases and dye absorption is reduced. On the other hand, lowering the temperature excessively can reduce yarn whiteness and affect product appearance. Chemical concentrations also influence swelling. Increasing sodium sulfate generally reduces swelling and increases whiteness. Similarly, higher acid concentration reduces swelling and may restrict dye penetration into the yarn. Since temperature and chemicals can influence swelling in different ways, they must be carefully balanced to achieve both good dye uptake and acceptable whiteness. Even when process conditions are well controlled, impurities can create serious dyeing problems. Trace metals such as nickel, copper, and manganese may enter the process through zinc sulfate or become adsorbed onto cellulose. These metals interfere with uniform dye absorption and lead to uneven dyeing. Lead contamination is particularly harmful. Increased lead levels reduce yarn whiteness and contribute to skitteriness defects that eye in dark yarn. Heavy metals present in the ash residue can form colored compounds that appear as streaks, patches, and shade irregularities. Therefore, strict control of raw material purity and spin bath contamination is essential for maintaining dye uniformity. Several additional process factors also affect swelling uniformity and dyeing performance. One important factor is sulfate deposit formation inside spinning pots. These deposits disturb yarn formation and often result in uneven dyeing. Regular cleaning and inspection of spinning pots are therefore necessary. Drying technique is another important consideration. High-frequency drying provides more uniform moisture removal compared with conventional drying methods and helps improve dye consistency. Additives must also be selected carefully. Some additives increase swelling and promote dye penetration, while others reduce swelling and restrict dye uptake. The correct additive choice depends on the desired swelling balance and product requirements. Why is swelling control so important? Uniform swelling ensures that dye penetrates evenly throughout the yarn, preventing uneven dyeing and maintaining shade consistency from batch to batch. Good swelling control also reduces skitteriness and other visible dyeing defects. In addition, it contributes to stronger and more uniform yarn with better textile performance. Conversely, poor swelling control can create significant quality problems. Low ripeness or low viscosity may result in inadequate swelling, weak yarn, and poor dye uptake. Excessively high ripeness or viscosity can lead to cellulose degradation, spinning difficulties, and yarn breakage. Improper bath chemistry and contamination can produce streaks, patchiness, and reduced whiteness, all of which are clearly visible to customers. To achieve consistent dye absorption, a disciplined control system must be maintained throughout production. First, all chemical parameters must remain within their specified tolerance limits. Second, spin bath temperature and composition should be continuously monitored to detect deviations quickly. Third, metal impurities and sulfate deposits must be minimized through effective housekeeping and quality control practices. Fourth, high-frequency drying should be used whenever possible to improve drying uniformity. Finally, additives should be selected and optimized carefully to obtain the desired swelling behavior. Together, these controls provide the operational foundation for producing defect-free viscose yarn. In conclusion, uniform swelling is not controlled by a single parameter. It is the combined result of managing all critical variables throughout the spinning process. The relationship is simple and direct. Uniform swelling leads to consistent dye absorption, while non-uniform swelling leads to dyeing defects. Strict control of ripeness, viscosity, bath chemistry, temperature, tension, impurities, and drying conditions is essential. By maintaining these parameters within their target limits, we can prevent skitteriness, streaks, shade variation, and patchy dyeing. The final outcome is reliable yarn quality, improved textile performance, and greater customer satisfaction. And if you found this content useful, please support the channel by liking the video, subscribing to the channel, and sharing it with your colleagues and friends.